So composition of functions is a topic that we almost always cover before we cover inverses, and that's because you kind of use composition of functions in inverses, and so it's necessary to kind of make sure we're okay with compositions before we do the inverse and stuff. Okay? And so this is not a mathematical definition by any stretch of the imagination, but we'll just say a composition, okay, of functions occurs when one or more functions are plugged into, or are plugged into another function. Okay. So that is a composition of functions. All right. If so, just as like a more general kind of notation thing, if f and g are functions, then a composition is denoted, and there's kind of two different ways to do this. One way, you can write F-O-G, like a little O like that, but it's like up in the middle. Okay, so it's almost like the multiplication symbol, but an open circle instead of a filled-in dot, right? Okay, F-O-G like that, of x, which really then just means that it's f of g of x. Okay, so g in this case is plugged into the function f. And then we can also do it the other way, of course, g of f of x, which is then just you reverse. F now is plugged into g. Okay. In general, will these two things be the same? In general, will these two things be the same? What do you think? See yes? See no's? I see yeses? All right, we'll see. Okay, let's do some examples. So given f of x equals 2x plus 3, and g of x is 5x plus 4. Okay, we're going to 1 find f of g of x, and then 2 we'll also find g of f of x. I gotta just write find. So for me, I never really liked using the f o g of x or f of g of x kind of thing like that. I like to rewrite it like this, just for my own kind of brain. Like this makes more sense to me, in my brain, with the g of x inside the f of x function, right? And so you can take this step by step, right? You don't have to do it all at once. So for example, g is inside of f. So instead of writing g of x, I can write f of, and then the function g of x here, which g of x is equal to. So since g of x is equal to 5x plus 4, I just do the substitution there. Okay. But of course, if you really wanted to, you could just skip down to this step where we then take that 5x plus 4 and plug it in for f of and plug it into our function f, right? So again, that 5x plus 4 is replacing the x there, so that means every x you see in the function rule also gets replaced by the 5x plus 4. So it'll be 2 parentheses 5x plus 4 plus 3, like that. And so then we distribute And we get 10x plus 8 plus 3, and so we get 10x plus 11. And you can do that in as many or as few steps as you need in order to simplify this. Okay, I'm spelling it out, very step by step for right now, but eventually I don't expect you guys to have to do that necessarily all the time. Okay, so 10x plus 11 is f of g of x there. Okay. So let's try the other one, right? G of f of x. Alrighty. So again, I'm going to rewrite it g of f of x. In this case now, we're going to replace f of x first, so it's going to be g of 2x plus 3. And then we plug that 2x plus 3 in for the x, so it'll be 5 times the quantity 2x plus 3 plus 4. And then we distribute 10x plus 15 plus 4 equals 10x plus 19, so g of f of x, 10x plus 19. Okay. So this is really one example, okay, and I hope that those of you that thought that f of g of x and g of f of x, in general, they would be the same thing. I hope that those of you that thought that was true aren't necessarily convinced just by this one example here, okay? This could be an exception, right, to what you were thinking, because again, I just said in general. So yeah, this is not necessarily confirming for sure one way or the other, I would say. But I think you'll get an idea as you proceed, with which way we will go, which way it does kind of go. Whether it seems to be more that f of g of x does always, or is mostly the same as g of f of x, or if they are not, in fact, in general the same. Okay, going to be the same. Right. But they're here, in this case, they are different, right? 10x plus 11 and 10x plus 19. And it was just two lines. Okay. We plugged one into two linear equations, two linear functions. All right, let's try another one here. All right, let's say given h of x equals x minus 2 and g of x equals x squared minus 4x plus 1. And by I mean example, actually I want you to try these two. Y'all try these here. So here we go. So you guys try to, 1, find h of g of x, and then also find g of h of x, please. You just assume you're doing something wrong, so look at your paper. So you correctly plugged in the x minus 2, right? But if you look at where's the no, okay, I see what you're saying. So there's more than one place to plug in. There's another x there. It's this. So you plug in the x minus 2 into the at x, and then another x. Plug it in. Oh, no. And then you're okay with what you... So, this is plus 1. Oh, I just... I think, yeah, you got the other one. Okay. So h of g of x. Right, to evaluate that means we're going to take our function g and plug it into h. Again, if you find yourself making mistakes, just try and take a few more steps if you need to. Don't skip steps. So we'll just replace the g of x with x squared minus 4x plus 1, and then that's going to go in. So it'll be, this will go in for the x right here. So x squared minus 4x plus 1 minus 2. So that's really easy to evaluate. X squared minus 4x and then minus 1, right? Because the 1 and the minus 2 go together. Okay, and so there's your h of g of x. Okay. Number 2, g of h of x. Okay, so again, it'll be h of x is x minus 2. So replace that, and then we'll plug those in. Now again, that goes in for every x value, right? So it'll be x minus 2 quantity squared minus 4 times x minus 2 plus 1. All right, so let's see here. All right, we square this out, right? We get x squared plus 4 minus 4x plus 8 plus 1, right? No, that's not how we square that out. It's x squared minus 4x plus 4, and then minus 4x plus 8 plus 1. Okay, right. You got to FOIL that out, right? X minus 2 squared is x minus 2 times x minus 2. I didn't see anyone do that, though, so. There it is. Combine like terms. X squared minus 8x plus 13. Okay. And there it is. Questions on any of that? All good now? Too easy? Too easy. Alright, let's try another one here. I got some more, though. We're not quite done. Close, though. Close. Okay. Oh, right. Okay. We'll do one more example here together, and then we'll have you guys try one more, and then we're done. Okay. It's pretty straightforward stuff today, I think, at least. Okay. Start with some more functions here. We'll say f of x equals the square root of x squared plus 9. G of x is going to equal x squared plus 2. Okay. And I'm asking us to find g of f of 2, not g of f of x. I want g of f of 2 here. Alright, so really, the only difference is, right, that we're finding an actual value. We're not just going to find some function. We're going to now plug 2 in where we have our x. And so, again, what you can do here, you can kind of break this down if you feel the need to. You kind of think, working from the inside out, right? Think of order operations. You do what's inside the parentheses there first. So right inside the parentheses there, right, is the 2, which we can't do anything with. But then we can go one more step outside, which is f of 2, which we can evaluate. So that's what we'll do first. So we'll evaluate f of 2, and let's just say that equals some number a. Okay? And then, once we know that, we will then evaluate g of f of 2, which is really the same thing as evaluating g of a, right? Once we know that f of 2 is equal to that a value, whatever it is, we just plug that a into g, and then evaluate from there. Right? So you can just take it a step at a time. You don't have to find g of f of x and then plug in 2 is what I'm trying to say here. You could do it that way. You could, plug f into g of x and then, get what simplified or whatever, then plug in the 2. You could if you want to do it that way, or you can just find it piece by piece and go from there. So we'll find f of 2 first. Okay. And so that's going to be 4 plus 9, which is 13, so it'll be the square root of 13. And then to find g of f of 2, that's the same thing as finding g of the square root of 13 then. And so then we just plug it in, right? So it'll be root 13 squared plus 2, which is then 15. Again, with, well, I guess, in this case, right, no plus or minus, the square root and the f function was, or the function f there was already given to us, and it did not already have a plus or minus in front. All right, we're not really solving an equation here, we're evaluating the function. The function does not have a plus or minus in front, so we don't have to worry about that plus or minus. We're just going to have the square root there. So. Okay, so it's just square root 13. And we get 15 as our final answer. Okay? Questions on any of that? Too easy, I know. We're all falling asleep. That's okay. Probably because it's Friday, too. And it's math class anyway, and first block, so everything's working against us. All right, m of x equals x squared minus 4. N of x equals 2x plus 1. All right, first, find m of n of 3. I should have named these better, I guess, but oh well. Okay. And then 2, if p of x equals x plus 3, find m of n of p of x. Okay. There you go. Just give this a try, okay? Yeah. A little bit here. Looks good. Yeah, that one's the only difficult one for that one is there's so many steps. We have lots of opportunities. Bless you. All right. Let's see what we came up with here. Ooh, that's not what I want. All right. You win, calculator. I'll just type it in. All right, let's go to Andrew W. Number 1, please. Yep. You can just tell me the answer if you want. 45 is correct. Okay. Whoop, that's frozen. There we go. Questions on number 1. Anyone want to see it done? Yes. Okay. So, Andrew, would you mind taking us a few more steps then, please? What did you do here?
2x plus, or, sorry, n3, so I plugged 3 into x for the n of x function.
Okay, so n of 3, and it was 2 times 3 plus 1 then, right? Is that what you did?
Yep.
And that equals 7? And
So
go ahead.
7 in for m of x,
Uh-huh.
for x and m of x, which would be 49 minus 4.
Mm-hmm.
And then that would be
45. Okay. See what you did there, James? Out of curiosity, where was your mistake? Where was your mistake? Okay, gotcha. Okay, very good. Thank you, Andrew. Let's go to Morgan. Morgan, number 2. Oof. You want to just give me going to give me your final answer?
Yeah.
Okay.
For m of n cubed,
Yes.
I got 4x squared plus 28x.
Okay, yeah, that's it. 4x squared plus, bless you, 40x squared plus 28x. Plus 45. Okay. Would anyone like to see that one done? A few people? Okay, very good. All right, Morgan, can you help us out here then? So, let's see. I don't even know where. All right, I'll go ahead and we'll substitute in the p of x, which is x plus 3. So it's n of x plus 3. Right? And then we're going to plug that x plus 3 in for n. So, gosh, I might just do that here as like a side thing. N of x plus 3. So it's going to be what? 2 times x plus 3 plus 1. Did you do in pieces like this too, Morgan? Okay, so what did you get then when you simplified that? Yeah, exactly right. Yep. 2 distributes to the x, 2 distributes to the 3, so we get 2x plus 6, but then the plus 1 there makes plus 7. So, yep. And then we want to evaluate m of that 2x plus 7. And so there's m. And so it's 2x plus 7 quantity squared minus 4. And then what did you get when you squared out that 2x plus 7? Well, I guess we know what you got. You got 4x squared plus 28x plus 49, but then there was the minus 4 there. And so then we get the 4x squared plus 8x plus 45. Okay. Questions on any of that? Questions on any of that? Alrighty. So like I said, that was it. Let's see here. The assignment that I'm going to give you guys is on a worksheet here. Abby has it there for everybody. Thank you.